Hello everyone, welcome back to the PETR1131 Petroleum Production and Process Engineering course. At today's lecture, we're going to have a discussion on the petroleum exploration. So before starting the petroleum exploration, let's talk about the background behind it, like the basic science behind it. So if you know, then you can actually have a better understanding how it actually works. So maybe all of you know about Batman, right? So I'm a huge fan of Batman actually. So let's talk about bats at first. How they actually see at the night. Actually, they can't see, right? What they do, they actually emit a type of signal, which is a very high frequency signal, and from there, that signal actually bounces back, and the bats actually got a good sensor, like its ears, and when it actually come back, its brain process that there's an object in there. Okay, so now based on the strength of that rebounded signal, as you can see here, the bat actually bounced one type of signal in here, and when it rebound, based on the strength of that signal, it can actually know, like, okay, this is a soft material or this is a hard material. Okay, it probably don't see the color of it, or it don't know what is that actually, but it can actually determine that what it could be, what is the obstruction, if it's like a hard object, like if the bat should avoid it, or if it's just a small insect, so they can actually fly through that. Okay, the same principle actually used by the whales and the dolphins also. Okay, a very same principle, and based on this actually we have developed our sonars used in submarines. Okay, so there's a thing, like now the question would be how it actually works. If you are familiar with playing tennis or cricket, then you would say like the field is usually like a pavement, or like the pitch, actually the cricket pitch or the tennis pitch is actually very hard pavement, not a soft like in the pitch. It would be really hard to play cricket in the pitch. Why? Because when you actually bowl, it won't bounce back. Why is that? Because the sand is soft and it absorbs the energy, okay, way more than the hard pitch. So when you actually, for instance, a bowler, when he or she bowled, after that, when it actually bounce, dropped, it don't actually bounce back very well. The same thing will happen with the tennis too. Okay, it's the very same principle. Now think about the sound. Okay, it's the same principle. Like, in a soft object, the sound would be absorbed, but in a hard object, the sound would be reflected better. Okay, so this is the same principle this sonograph actually work, because the bat or the whale or the submarine, we call this sonar because it emits the sound, a very high frequency of sound. Okay, so is it easy to play a cricket or tennis in the beach? No, it's not. Why? Because the sand is really soft and it always absorbs the energy to bounce it. So not only the ball, also it true for the signals. Okay, so this is the basic science behind it. Now let's learn about the exploration. Now the first chapter, what we actually learned are mostly about like the geological features. Okay, that's the previous like background, and from now we're actually entering how we actually determine where the oil and gas reservoirs could be found. And once we can actually found the oil and gas reservoir or a potential oil and gas reservoir, we need to actually explore it very well. And why we need that? Because we just can't just go and drill somewhere, because it would be very expensive. So we want to make sure the exact location where we should actually drill, and that's exactly why we need to do this exploration and this like kind of like a background, I mean basic groundwork we have to do before the drilling. Okay, so the first thing we do is exploration. After that we analyze the data of the exploration. Okay, and after analyzing the data, probably we'll actually do more exploration activities. Okay, and then we actually come to a decision, and that decision would be based on these exploration data. And from there we would actually proceed like should we actually move to the production or not, it would be economically viable or not. Okay, so that is exactly why this exploration part is very important. Okay, so based on the data from the exploration, we actually will decide should we go for the drilling. And when we actually drill, after that, if we get the oil or the gas, we call the production team, they come over and they start the production. But it might also happen that you drilled and couldn't find anything. Okay, then what you need to do, you need to do the exploration again. So there is a process of doing these steps. Okay, so that's exactly why the exploration is very important. Now, how we actually do the exploration? So the first thing we actually, like the ancient thing we did, like look above from the airplanes and take the real photographs or from the radars. But this collecting this topographic data would be very expensive too. Okay, you can see like the thousands of square miles or kilometers, or you have to charter the planes and the aircraft. We call these taking the aerial photographs. Now we have drones that actually replace these types of aerial photographing, and the drones actually make our life really easy, and we don't need to actually take the aerial photographs by a human. We can just fly a drone and it can actually take the aerial photograph to us. But sometimes these aerial photographs are not enough, so what we actually do, we take the photographs from the satellites. Why? Because satellites, it can gather more data and different types of data. For instance, it can actually give us the thermal data also. Okay, so not only like the visible picture, if it actually gives us the thermal or infrared pictures, then we can actually get more idea what types of rock formation could be in there. Okay, and it would be of course more cost effective too. So this is a picture, like an image of the satellite image. Now if you actually go to the Google Earth, then you can actually see a very similar picture to that. Okay, so it actually save a lot of our time and lots of resources. So this is actually another enhanced picture of using the Landsat satellites. Now NASA got lots of satellites, and if you want a spatial type of satellites, especially exploration for the oil and gas industry, so the oil and gas industries, they can actually submit the requisition for the image, and NASA will capture those images and they will sell it to these companies. So that's how it actually works. Okay, so from the above, what we actually look for, we look for the naturally occurring seepage or the evidence of there any kind of seepage happened before, or a certain types of rock formation actually can see, so that we can actually narrow down our search. Okay, so for instance, there are lots of reservoirs actually we found. Some world's greatest oil fields has been actually discovered from the natural surface oil seepage. For instance, the Athabasca tar sand, that's actually found through this way. Okay, so that is the important part of the exploration. Now, this from this oil and gas seepage, we can actually detect, we can actually even see the fracture. Okay, and from there we can actually determine, like, okay, that's how we can actually see, like, okay, there is evidence of oil seepage, so there could be potential oil and gas leak over there. Okay, so the seepage could look like exactly like this. Now, except for this visual identification, we have different types, other types of surveys. For instance, electromagnetic survey. Okay, so how this electromagnetic survey actually works. Now, rock, it have different types of magnetic field. Okay, in fact, every types of material have a different types of magnetic field. For instance, like the igneous rock, its magnetic field would be very much different than the sedimentary rock. Okay, so this variation in this magnetic field actually give us the idea about, like, the different types of rock in there. And as you know, like sedimentary rocks is a potential type, like we can find the oil and gas, so that could actually give us a lead, like, okay, probably we can find oil and gas reservoir in there. Even, like, I mean, if we got the igneous rock, it could actually be the basement rock. Okay, is usually the magnetic, which doesn't contain the hydrocarbon, but it may show us the structure where the hydrocarbon may hiding. Okay, as we have seen before the slides, like how the trap actually work, right? So igneous basement rock can actually act like a trap. Okay, now this is how the geophysical survey actually works. It's actually showing the offshore geophysical surveys. Now there is another different types of survey. We call it gravity survey. And how it actually works, because the gravity is not constant, we all know that. Okay, so a very slight difference of the gravity we can actually measure. For instance, the igneous rock, it's more, I mean, denser rock exerts more powerful gravitational force. For instance, the igneous rock. Okay, and the sedimentary rock would be more lighter, right? And metamorphic rocks would be in between. So for instance, like the anticlines, which is consist of the igneous rock, would be the maximum gravity. But the salt domes, which is mostly the sedimentary types, got the minimum gravity. So that's how we can actually measure the difference of the gravities by these types of machine. Okay, we call it gravitymeter. Okay, so this gravitymeter actually measure the local gravitational field of the earth, and that's how we can actually determine the gravity of different types of rock, and it will give us the better understanding what types of rock in there. Okay, now, well, like, I mean, these gravity survey or this electromagnetic survey, those are like pre-surveying. Like those can actually get some data and narrow down more give us more information and narrow down the field. But ultimately, we actually do the geophysical survey, which we call the seismic survey. And seismic survey is a type of survey we use the same principle as the bat or even the whales. They actually use this sonic. Okay, so let's know how the seismic survey actually works and what's the history behind it. So typically seismic survey is the last survey, okay, the final one, and it is based on the acoustic sound. Okay, it listens to acoustic sound to the underground. It has been developed by the German physicist Mintrop, and the first time we actually used that in World War I to locate the artillery. Like lots of great inventions actually we have invented during the wartime, although we don't want war, but it's actually give us a lot of inventions too, especially World War I and World War II. So these the first use was at the wartime, but later on we actually adopted this technology and used it for a peaceful purpose. For instance, like setting off the underground charges, like the mines or the bombs actually planted during the wartime. When you actually want to dispose these bombs, you have to locate it, and the seismic survey, using the seismic survey actually helped to set off these underground charges. And later on, it's actually used to surveying the oil and gas. Now, how it actually works, the earlier time we actually used, like for instance, we set off the explosions, set off the explosive charges, and if there any explosion occur, then what will happen? The signals from these vibrations from these explosions will be gone through this layer of the rocks, okay, and then it will be reflected back to the sensor. So we have the sensors, which we call the seismometers, okay, and this vibration data actually collected by the sensors. But the problem is it's not environmental friendly, and also it create a lot of like panic, and also it's very expensive. So now we use a modern method. We instead of using the explosive, we actually use a truck, a type of truck we call the vibrator truck. Okay, so this vibrator truck, it sends the signal. The working principle is very similar. It sends the signal. Okay, it emits the signal, and as you can see, we actually put the sensors, okay, on the ground. We called it geophones. Okay, these are the geophones. So remember, at the ground, the sensors, we call it geophones, and at the ocean, the marine environment, at the marine, we call these sensors the same type of sensors we actually use, but we call those hydrophones. Okay, so these geophones are the type of sensors. So when the vibrator truck actually do the vibration, and after that the signal actually reflects back, and geophones catch those signals, and from this signal we have the idea, like what is the density of the material inside. So for instance, like the gas would have the lowest density, after the oil and the water, and then the rocks, like igneous rock for instance, would have the highest density in here. So based on this density difference, we can understand, like what would be the signals. Okay, it's pretty much straightforward actually. So these are these trucks, as you can see, these thumpers. Okay, so these impactor trucks, it drops 6,000 pound steel slabs from high as 9 feet to the ground to create the shock waves. Okay, this is how these shock waves actually created. Now some of these actually use the mixture of propane and oxygen to use the expandable chamber and create the explosion inside the chamber, and that's how actually it works. So there are various types actually like that. There is another type, it's the abrasives also. Okay, we use the continuous low frequency sound waves with the reflector. Okay, so there are, as the time goes by, we actually improve more and more and goes to the mirror perfection. Okay, as I said, like the marine seismic methods are in a very similar way. Okay, we call these sensors as hydrophones. Okay, so the ships actually use the air gun, okay, to send the sound wave under the ocean and the water and the formation beneath the seafloor, and when it actually reflect back, it actually catch by these hydrophones, and then we can actually get the data. Now about the seismic survey, like please go to this link, this YouTube link, and you will find a video about the 3D seismic survey, how it actually been done. So please watch this video. It's a very important video. Okay, so please go through this video and you will have more better understanding on the lectures what I actually explained in this previous slides. Now when you actually do all these surveys, after that what you have lots of data, and from this data you have to interpret, okay, how these data actually lined. So there is a these are the seismic results, and there is a web page for the CNSOPB, which is Canada Nova Scotia Offshore Petroleum Board, and there it is actually to find the potential traps and the reservoirs. Okay, so this would be a perfect case study for you to see, like, I mean, if there any oil and gas is near the offshore of Nova Scotia or not. So you can actually go here and you can find, like, I mean, what are the potential areas. Okay, and as you can see, these are the domes. Okay, these are the domes, and these are the faults. You can see the faults, and this is the domes. Okay, so these are the potential zone for getting the oils in the faults, okay, or near the domes, right? And these are the aquifer, the water reefs, and this could be a potential zone for the natural gas, right? So that is exactly how we actually determine, like, how this actually works, and how we actually knew like there is a potential zone, because there is a seepage of the gas happened in here, okay, and the oil actually showed in here. So that's how we actually determine. So how we can determine, the more we'll actually go deep down to the course, the more we'll actually know how this actually works. Okay, so this could be a case study for you. So we'll see that again later on. Let's go to the slides. So the reservoir developments, when you actually deploy the exploration team, so what they do, they actually collect the data. Okay, now how they actually collect the data? They actually collect the data during the so once you actually do the seismic survey, and after that you find the potential zone. For instance, give you an example, here could be a potential zone, here could be another potential zone, okay, here could be another potential zone, right? So you identified, like, okay, so these are the potential zones. Now what would be the next stage? The next stage would be you will drill, okay, you will do some experimental drill, and after that you will collect you will actually send some sensors, and these sensors will actually collect the data, and from this data you will actually interpret. Okay, you will interpret the data, and then you will find like, okay, there could be a chance of finding the oil, or there is no chance, that there is only water or aquifer or something. I mean, there is no possibility. Okay, so how will actually do that? We actually do this by the logs. Okay, so when you actually start drilling for the exploration, okay, when you actually get the surface data, and from there we'll actually start drilling for the exploratory well. Okay, and during the drilling process we collect the rock cuttings, core samples, and the most important part is the well logs. So what are the types of well logs we have? So we have the driller's log, and the driller's log is the basic written logs. Okay, it's created by the person or the driller. We don't use any much of machines or anything. We just drill, and we just write down like, yeah, here there's the fluid. We find like fluid after 50 feet, and we drill more, then we find like igneous rock after 80 feet. These are like the driller's log, and this is very, very basic. Now there is another types of log, we call it wireline logs. So it provides more complex interpretation. So how it actually works? So for instance, we start drilling, and drillers start writing down their logs, and after a certain depth we actually send some sensors inside through the wire. Okay, so the hole has been created. After that we actually put some sensors, and those sensors are known as sonde. Okay, so these sondes actually send the drop down, and it will give us the type of different data. What are the data we have? We have the data we'll find based on the type of the sensors. Okay, so the radioactive sensors, electrical sensors, acoustic sensors, we have different types of sensors to get different types of data. Let's see what are the types of sensors we have to get the different types of data. Okay, and these data, when we will actually get all this data, we'll actually translate into the graph. Okay, and this graph will look like exactly like very similar to this one. We'll see more. Okay, so the sonde or the sensors that measures and record, as I said, electrical, radioactive, or acoustic properties. Okay, so the electrical log or the electrical sensors, it gave us the information on the water content. Okay, water content in the formation. How? Because water got some resistivity. Okay, water is dipolar type, right? So it got some sensitivity and resistivity, and also there are some salts actually dissolved in this type of water, right? So from there we can actually get some data on what types of water and what is the salinity of the water. Okay, so these are the informations we will get from this electric log provider. Radioactive log, it actually gives us a type of rock or types of rock, the porosity, the salt water, or like the oil gas content in the formation. These are the information we'll actually get from the radioactive log. Okay, acoustic log, from this acoustic log we'll actually can get like how dense the rock formation is. It's very similar to what I explained before, like the how bat actually see their path through. Okay, it sends the acoustic signal, and when it actually reflects back, it actually gives us the idea on the density of the material, right? So it's the same process, same principle actually used. So this is a kind of like example. So when you do the first, we took the aerial survey picture, and then we are confirmed like, okay, so there could be some potential sector, and then we deploy these trucks, and they do these they do the geophysical survey. And after the geophysical survey, when we make sure like, okay, so there is a possibility the oil and gas could be found, then we start exploratory drill. And when we actually drill, then we send these sensors. So these are the sondes or the sensors. These like look like these cables, okay, so to get the logs. Now the field actually looks like that. Here is the geologist trying to see the computer analyzing the data real time from the sondes. Okay, so this is how actually it works. Now the electrical logs. Now the electrical logs, it actually, as I said, it gives the different types of sensors on the resistivity. For instance, like the water, as I said, water, it actually shows like the amount of the water, and it also can show the permeability of the rock. How? Because the water, from the quality of the water, you can actually also determine like how permeable is the rock. For instance, if the signal shows like there is a less presence of the water, that means like the aquifer is not permeable at all, okay. But if it presents more presence of the water in that aquifer, that could actually give us the information, okay, so the rock is the porosity and the permeability is higher, okay. So that kind of like, I mean, information the electric logs actually could give us. The radioactive log or the nuclear log, so the gamma ray actually give us, I mean, information on the type of the impermeable rock or the rock shield or the clay. And so this is a type of log we have, the gamma ray log. And we have another types that we call neutron log, okay. So what it does, it shoots neutron to detect the hydrogen atoms, and these hydrogen atoms actually slow down the, because the hydrogen actually slow down the neutrons, okay. And from there we can have some idea like is there any hydrocarbon in there or water, okay. So if there is any hydrocarbon, we'll have a different types of signal than that of the water. So that's how we can actually detect the hydrocarbon from the neutron log, okay, remember that. Acoustic log, from the acoustic log we can actually get the different types, like, I mean, it can actually give us like what types of rock it is, and also give us the information on porosity, okay, if the rock is porous or not. For instance, if the rock is more porous, you can have soft you can have a soft signal. But if the rock is more porous, you will have very hard signal. That means the bounce back would be more harder, okay. So that's how we can actually get idea like what types of rock there could be from the acoustic log. Now when you actually get all the different types of data from different types of sensors, so what you will actually do, we actually put all together in one chart, okay, and from there we actually try to understand like, okay, what would be, how actually it interprets, and from there we actually map and make a zones like, okay, so there could be the water because it shows like that, there could be this type of rock, there could be that type of rock. So here if you actually see, go to there, then you will find, okay, so this is the types of different signal you combine, and after that then we'll see like, okay, so this is the type of different types of rock or aquifers, and from there you'll actually do the more refinement and create a chart like that, okay. So that's how we actually create these complete 3D seismographic charts later on from these types of data. And there is another very important thing, is the core samples. So we just don't drill only for sending the sensors. We also get the samples, the core samples from the underground. And based on the core samples, we actually have different types. We have the core samples of the special drill bit. It goes and it takes the sample of the rock, and it also get the samples from the recovered debris from the drilling process, which we call the cutting samples. Okay, so these are like the example of core samples. Now after this getting the core sample, we do the testings. Okay, and from the testing we do the analysis. We do the testing for the core sample, like the drill stem test and the stratigraphic testing, and from there we can actually make a stratigraphic correlation. So it correlate with this core sample data and also our data from the sonde. Okay, and that's how we actually, this is how we actually do this correlation. And then our ultimate goal is actually to create a chart like that, right? So this is how we actually do that. And yeah, from there we actually create these contour maps. If you actually go to our reference, then you can see the contour maps also. Okay, this is how we actually do this contour maps. And again, the vertical section map, and this is the vertical section map we're actually talking about. So this is the 3D models, how we actually develop. That means we do the analysis, we send these are the drilling exploratory drillers. So we actually drill through the mud, and then we actually send the sondes in different areas. Okay, and we collect the core samples, and from there we actually do the we analyze the data, and then we actually combine, and then we actually generate this 3D seismographic model. Okay, exactly looks like that. This is actually 2D, but we can actually extend it 3D if we have more drilling rigs if we got. Okay, so this is exactly how we do these maps and modelings. So what we have learned, so we have seen how we actually start to do the exploration. So the first basic step actually we do the exploration from the above, taking the pictures and get the potential site, and from that we actually narrow down. Okay, and after narrowing down we do the geophysical survey. Okay, and from there we narrow down again, and after that we start the seismic survey. Okay, and we actually narrow down even more, and after that we actually start doing this drilling, experimental drilling. Okay, and exploratory, we make some exploratory wells, and then we collect the data and also the rock cutting samples, and then we actually correlate all the data. We do the data analysis and we do the curve fittings, and after that we get a reservoir model exactly like that. So this is how we do the exploration of the oil and gas. So our next lecture would be based on the mineral rights, and I would actually suggest you to go through the reference I actually gave you, and the reference, the Introduction to Petroleum Industry by Fagan. Please go to this book. This is a very easy and simple read actually. So if you actually go there, you can actually get more information actually how to do the how it actually works. So all right, I will actually move to our next lecture. Okay, it's the mineral rights and reserve. So again, thank you everyone, and good luck. Bye.